Hello, world. Welcome to episode 29, building our podcast monitor app. Last time we went over the Diff-Match-Patch module in a kind of a broad sense and added some episodes here that we can do some comparisons on and set up all the structure. So this time we're going to kind of fill out the test and then start using that module to do some scoring and comparison. So let's get started. I'm going to add in, let's just change this, test the quality, and this fails. This should fail. Tests, episode, quality, yep, because they're not equal. So let's add a bunch of these in, and we'll also compare the rule of 2 with this rule of 2, and then we'll compare, let's do, well, I guess we could compare, yeah, I'm actually going to take this one. So we'll compare a couple letters. So we have these, which are kind of across, so actually I'll do these two first. So we're comparing these episodes, which are exactly the same. So those should have the precise, exact same scores. These should have slightly different scores, but should still be considered equal. And then we'll have some not equals down here. And we'll do this one, and this one. And then we can also do this one. And we'll take these two and do these two. So we have a kind of a variety of things to test on. Okay, so git commit, filled out, episode equality test, tests equality. Okay, and this should obviously still fail because, so these would actually pass down here because they aren't equal, right? So like, let's say we would have just real quick, now the test should pass because none of them are equal. If we had these two back in, it should still pass. So these are the ones that are causing the issue because they're not exactly equal, but they are the same, right? And so we basically want to get it to pass with those while still having it fail for these and having it pass for these. And in fact, we could also add in we could also add in a score, like the score, like we could say, well, these should be exactly equal, these should be close to similar. I'm not going to do that right now because I don't know exactly how I don't think I'm going to lay out the test kind of in that way. But one thing I want to do for now is I'm going to add in some prints, because what I'm going to do is I'm going to, when we're doing the equality here, I'm going to start printing out the score information. So that I can kind of tweak it a little bit. So let's just say MC versus MC. And we'll just add that to all these. And then we'll just need to update it. Alright, so now, still the same thing, but basically, right, so we're kind of getting that, these, and we're going to, now we can kind of print out, when we print out the scores, we'll be able to easily kind of see what the different things are. So I'm going to open up episode here. And so we're going to need to, from Diff-Match-Patch, import Diff-Match-Patch. And in here, we're going to say DMP equals Diff-Match-Patch. Let's check out the prototype real quick. Okay, so we have that DMP Diff-Match-Patch, and so basically we're just doing this sort of deal, the diff, and then the Levenstein score of the diff. If we look down here, right, so when we're comparing stuff, we wrap them in strings, and that was only. These are strings. That was only, I think, when I was doing some of this other stuff. So we don't need to do that. I'm going to probably put a specific scoring function for each of these attributes to make everything kind of clear. So we'll have two functions kind of like this. So we're not going to use this sort of thing here. And then we'll have some of this kind of scoring too. But basically, we don't need the prints, we just need these, and then we're going to return the score. So this is the only kind of important information here. All right, so let's say in here we'll say def score title. And so the diff is going to be, so we're going to call the DMP module Diff-Match-Patch, diff main, and we're going to want self title and other title. So that's the diff. Then the raw score is just going to do that. So then the other thing I wanted to do was I wanted to normalize and weigh it. Right, and so normally if you're going to normalize data, and this isn't like something, I'm not like a data scientist, but, right, and this should be value. You're going to, basically say, okay, so that you have a range, right? So let's say you have all the data, you take the lowest value and the highest value, and you have your value somewhere inside of that, right? And so you take the difference between your value and the lowest value, and then you take the difference between the high value and the low value to get the total range, and you get the proportion of your value to that total range, right? And that gives you a number between 0 and 1, right? So normally, if I were to say, if I had all the data, right, I would know the low value and the high value. And I would just say normalize is, in this case, raw score minus the low divided by the high minus the low, right? Now here we don't have the low and the high because we don't have all the information, right? But those are going to be kind of parameters that I could kind of tweak, is the way I'm kind of thinking about it, right? So when I was looking at this information here, right, the titles that were good so the titles that were good, which were stuff like the rule of 2, right? So this rule of 2 versus this rule of 2, and this MC versus this one. These were different by less than 10, because this one has this in the front but was otherwise the same, and this one has capital up here and lower and regular cases down here, right? But ones that were completely different, such as comparing this one to this one, were off by around 50. Now, when you look at the descriptions were exactly the same, so they were 0. But the other descriptions, right, when I was comparing cross, if I compared this one to this one, they're completely different, and they have scores. So even though, essentially, right, even though this and this are completely different, and this are completely different, their scores have to do with their length, right? But they don't have solely to do with the length because, for example, this has a difference of 49, but this and this here, right, are under that. So I can't say like just divide it by the length and kind of give me something. So that's why what I'm going to do is I'm going to say experimentally, essentially, I'm going to determine kind of a low and a high score. So the low is just going to be 0 because it's always positive. And so the high score, I'm going to say, because of the length, like, so I could calculate the high score based off of, like, let's say everything was completely different, right? The high score could be, you know, the lengths of them combined, I could say, but that's probably too high anyway. But in general, the titles and descriptions are probably going to be able to, some sort of, you know, well, I mean, essentially, the way to think about it, because I'm also going to kind of cap it in the end. So let's say the score, let's say I put the high score as 50. Well, then something that is above 50 is just going to be, instead of 0 to 1, it's just going to be more. So if I get something that's a difference of 200, it's going to be, instead of from 0 to 0.0 to 1.0, it's going to be 2.0, right? But now, if I capped it at 50 and now the score is 100, so it's got a 2.0, do I care that it's that different? It's clearly very different. And so I could just say, well, that's a 1.0. It's completely different, right? And so what I'm going to do is I'm going to say, you know, based off of this kind of experimental data so far, and that's why I'm going to do some compare. That's why I'm printing things out. I'm going to say 50 for now. Then I want to do is I want it to be between 0 and 1. So I'm going to take the minimum between that score. Oh, okay, here actually let's say normalize, and then we'll say cap equals the minimum between the normalized score and 1, and then wrap that in the maximum between whatever that is and 0, right? So if for some reason it was negative, which it shouldn't be, it'll just make it 0. If it was for some reason over 1, so let's say the normalized value, or let's say the raw score is over 50, right? The normalized value will then just cap it at 1. So I will have a value between 0 and 1 with some decimals in there, right? And I'm not going to do the weights right now. And then I'll just say return cap, right? Now, obviously, I could do this basically in a few lines, right? Like I could basically substitute all this into raw score. I could wrap that in there, and so I could do it in significantly less lines. But for now, I'm going to leave it like this, so it's just very clear what I'm doing. I can get rid of this for now. We'll have to do the weighting too. Comment that out. And then we'll say, so let's just start with this. So let's just say we'll need some sort of threshold. And in this case, let's just go with 0.5 to start with. I think I'm probably going to reduce that, but let's just say 0.5 to start with. And then so we're going to, total score is right now just equal to the score of the title. And then we're going to return total score is below the threshold, right? And so now let's run this. And it passes, right? So that's great. And that's because with just one parameter, we're able to get the score of them and kind of calculate all of this. So now what I want to do is I'm going to print out, I'm going to say print title raw score normalize, and then I guess cap too. So now if I run this, and let me add a couple. So now if I run this, right, I see that For the ones that, so I'm just looking at the title right now, so we don't even care about that. If I'm looking at the ones that are exactly the same, which is these first two, the raw score is 0, so they're exactly the same. If I look at the ones, these next two are the ones that are similar, but not exactly the same. So the raw score here is 5 and 7. When I normalize it in that range, I get 0.1, 0.14, and there's no need to cap it. Now, if I compare across them, so this one is now 56. So that one actually goes over, and so I just knock that in as 1. If I compare it, so this is the Mystery Crate episode on the main to the Rule of 2 episode on the main. If I compare the Mystery Crate on the main to the Rule of 2 on the Mystery Crate feed, it's 0.9. Why? Because this one and this one, which we actually compare right here, are slightly different. So that 7 here, well, this is 56 and 49, so that's interesting that it is additive in that sense. And then if I look at these ones, these are different. 39, so we get a 0.78, 0.68, right? And so the one thing I might consider is lowering the threshold, because if I look at the title scores, the ones that are exactly the same are 0. I don't need to worry about those. These ones are very close, 0.1, basically, below 0.15, 0.1, 0.14. The ones that are different go from completely different on this one to this 0.68. So a couple things I could do here, right? I could, for example, increase the high value, and let's see what effect that has. Oh, now we get a failure. And actually, which one did we fail on? That's interesting. Assert equal, Mystery Crate. Okay, so these two aren't equal, but now they're coming in equal. So this is the MMC and the MCROT. MMC, MCROT, right? So these were ones that were... so basically what happened, right, was if you look at it, so look at the one above it that I actually get here for the MCROT. Here goes from 0.98 to 0.49. So these are still 0. These are now ridiculously low, but these are now getting kind of lower. So I'm basically pushing everything down, and in fact, I'm actually taking something that was apart by around 0.9 to being apart by, right, 0.5. And so I think I'm going to go low. I'm going to go back to this one. And the reason being is that, without the cap, right, I could increase the cap if I wanted. Or I don't want to increase the cap because I want it to be 0 to 1. But anything that's kind of this high is definitely different. So I don't need to worry about that. I think what I can do, though, is lower the threshold. Because if this is going to be 0.14 and this is going to be 0.68, then I could lower it to 0.25, right? And I'm still going to get them all to pass. And this one is now this one, these two, which are definitely completely different, are going to be even farther off. All right, so that's just the title. And so now we want to do the same thing for the description. So add this in here. Let's just, this one's actually going to be exactly the same. But for now, I'm going to have it as two different functions. We'll look at later if we want to refactor it. And so here we want the descriptions of each. We get the diff. So this is here where these ones which are exactly the same are 0. And this actually was something that was interesting where they were exactly the same, even in the episode was different. People uploading it put different titles, but just left the description. So the descriptions here, though, for ones that were different, were in the several hundreds range, right? So here we could do something like 500, maybe even 1,000. Let's start it there. This is going to be description. And then we normalize, do everything in that. And then here we'll say plus score description. And now we have 2, so we got to divide by 2. And right now they're equally weighted, right? So inherently here it's we'll add in weights later. But right, so now we have these 2 things we're adding in, and we're basically taking the average of them. So let's print this out now. And now everything still passes, right? These are still exactly the same, so they're still going to be 0. These descriptions are the same. So if we actually also, we can print out another one before. Let's print out total score equal, and we'll say total score less than threshold. And this needs to be an F string. All right. Okay. So let's run this now, right? So, total score. That's what we wanted. Okay, so now total scores and these are 0, these are equal. So now because these descriptions are exactly the same, it actually cuts this in half, which allows the threshold, right? So now it takes it below 0.1 for each of these. So if the description was slightly different, so let's go in here. I'm going to change one of the descriptions slightly, and we're going to see what sort of effect that has. So let's say, so these descriptions are exactly the same. We'll remove this. We'll make this a separate sentence. And touch on that. All right, so right, we're just making some changes, so now they will be slightly different. So now let's see how that affects this. So everything still passes. So now we see this. So wait, which one was it? ROT, right? So this is this one here. So now the description is slightly different. And so now it's different, but it's still kind of close, right? It's still saying the same thing. We could probably try to increase the score a bit more. But now it's a 0.16, right? And so 0.25 is the threshold. So these descriptions, so everything up here stays pretty high, right? So before it was a 1 and a 0.7. Now with the 0.71, it actually decreases it to that. This, right? So we could probably lower the score. 500 is probably too high. These are all completely different. These are pretty close. So it looks more like 3 to 350 is probably better of a range there. Because we don't want these to necessarily make them closer. The descriptions are, as we said, completely different. So let's do that. Let's lower these to, I'm going to say 325, just because this one's pretty low. But the others are higher. So let's do this now, right? So still, everything is good. If we look, we have, so this one here, right? So this actually goes up in value because this one's at an 83. And this caps at a 1, right? So here it actually increases all these values a little bit, right? So the title was this. So right, this is where we kind of want to play with the parameters and decide, right? Like I don't like the fact necessarily that now this one becomes so much higher because that range is lower, and that pulls this up from a 0.14 to a 0.19. That also being said, we manipulated this one and it still passes, right? But arguably, because these descriptions are the same, right, we might want to weight that more in the end. So we'd also want to kind of consider that too. I think what I'm going to do is I'm going to bump this up to 350. And I'm going to undo those changes. But we'll have to see, like maybe we want to add in a test that has kind of a description that talks about something similar. But again, all the descriptions that match. So in theory, this is more of a realistic test of what we're actually testing. So we can make it more accurate in theory, but the reality of the situation is kind of what this is. All right, so now we're going to add in score. We don't want to do the publishing date because we don't actually care about that. And def score, what was the last one? MP3. Okay. And so we look at the prototype, right? So these are slightly different because they're not precise string, or they're like, right? This. So the reason is like the string difference of these. So, and I think I might, yeah. So if you look at like the length of seconds, these are 0. This is 0. Or this is 5, right? But taking it as a string is kind of weird because these are going to have like low differences between them. If you count them as strings, but the actual time, right? This is seconds, and so that is actually kind of what we want to say. Is we want to say, oh, well, this one's like 5 minutes different, and so we actually want to do that with an integer. So we actually don't want to. We're not going to use the Diff-Match-Patch is for strings, so we're not going to use that. We're going to use this here. So let's come over here to episode. And in here we're going to say v1 equals self dot or self sec, and v2 is going to be other sec. These are integers, so we're going to take the max, so that way whatever one is, we don't know which one's positive, right? So one of these is going to be bigger than the other, so one value is going to be positive, the other is going to be negative, so we're going to take that. The reason I was dividing this by 10 was as a scale factor, so I'm actually going to take that out. So I'm going to say the diff is that, or actually, so let's do, this is the raw score, and then low high equals 0 something, oops, something, and then we want to normalize and cap and return it. So we can basically take all this and add this in here, update this. So what's a good high value, right? And so this is in seconds. So if the difference, right, so if you're looking at, like if we're looking at, you know, these have the exact same one. So they have no difference in time. If we're, however, looking at, say, this one and this one, right? The difference is 1,083 seconds. So if we divide that by 60, it's off by 18 minutes, right? And so that's a pretty good amount of time, right? I would say, so if it's off by 5 minutes, which is 300, that could just be like a difference in ads, right? They could just have basically a couple more ads in there, but it could be the same episode. If it's getting off by 10 or 15 minutes, there's actually probably at least a different, it could be the same episode, but maybe they uploaded one with kind of more content in it. They added, they kind of did stuff slightly differently. In fact, there was one that came up on Friday. It was the same episode, but it was a 4-minute difference, and that 4 minutes was ads. Sometimes the main show has a difference, especially if we brought in like YouTube into this. We'll have a difference on an episode of like 10-ish minutes. And that's because they kind of cut it differently. Sometimes, though, it gets up to like a 15-20 minute difference. And that's because it's literally like they added, like they just only showed like part of it. They only kind of recorded both video and audio for parts of it. So I would say 30 minutes is probably a good difference. 30, or if we do 15, so that's 900. So why don't we say about 1,000, actually, right? Like, I think once you start getting over the 15-minute mark, questionable if we want to say it's the same. Maybe if we do want to do, especially with now these are always kind of very similar, but if we started bringing the audio kind of clips, you might want to say, oh, this is the same episode, but this one's long. But then we probably wouldn't compare length of time for the equality here. So for this, we'll say 1,000. And then we will add in score description. All right, let's exit out of this. Everything still passes. So again, the ones that are exactly the same, zeros here, zeros here. So these are significantly... Oh, I need to divide by 3. All right, good. Still passes. So this one's also now significantly kind of bringing down this value here. These values are all kind of capping out at 1s, so these are getting very close to 1, which is good because they are completely different, right? If we did introduce, right, and this is 0.8. If we did introduce one that was kind of, a different description, so if we went back into here, and let's add this back. And now let's kind of run that one and see what happens with it, right? So now this one here, this is still low. Oh, I didn't change this. No, I did change it. Oh, I'm scoring the description twice. Okay. So now if I'm looking here, right, so very low. So this is still pretty low now, right? So even though this, like, right, we made, we changed the content of the description. It still talks about stuff that's very similar, but because these are also low, even if the description did kind of change a bunch, this still makes it pretty low. So I think that's actually that's actually pretty good, because these are very low because it's just differences in the titles. So then let's come back in here. We'll invert that again. All right, and the last thing to kind of consider is these, right? So if we look at, so these two compared to these two, so there's just the one in between them, right? So if we look, this up, like a bunch of this here, this is the same, this different feed has a completely different, so it's still the HTTP pod tracks redirect, but then this one goes to traffic.megaphone.fm, this one goes to pdst.fm, chart.fm, track, and then the track is completely different as well here, right? And then this has a traffic.megaphone.fm. Well, this just has this MP3. So these MP3s are different, and that whole inner chunk is different. But what isn't different are, right, these. These updateds are the same when the episode is the same. So that's what we want to do. And so that's why when you look at the prototype here, what I did was I basically grabbed that ID by doing this find, right? So find the location of that, add the length so it goes to the end of this equals, and then go to the end, because all of these basically are of the format where it's just I want this last ID. So find this, and then basically just get whatever's after it, right? So that's what this is here. And for V, we'll call this URL. And we'll say URL.find, and okay. Okay. And now for this one, raw score diff. So this is going to be self MP3 or other MP3, and then so here we have raw score so basically I just said it was kind of half the threshold. So here what I'm going to do is I'm going to give it a raw score of 100 if they're different, otherwise it's 0. And then I'm going to normalize and cap low high. So I don't really need to normalize or cap it, right? Because it's already, well, I guess I could just say 1 to 0 then, because it's either 1 or 0, right? So it doesn't really matter. So I don't need to do this. I don't need to do this. I don't need to do this. And then I can just return raw score. Because this is just a true or false. It either is equal or it's not. Go over this. Here, this is going to be a 4. And score MP3. Okay. And so, yep, everything still passes. Right. So this basically just kind of bumps up these. These are all the ones that are all different have a 1. These ones that are all the same have a 0, and so it just kind of helps reduce and stuff. So get rid of that there. And so the thing we're gonna have to consider is how to weight them. That was right. How to weight these, right? That's basically the last thing we're going to kind of want to consider here. And I'm going to leave the prints in while I do that. So what do we have here? Gift status. So we added in all this information. And that. So I'm going to say... git add tests Actually, no. It's not the one I want. Git restore staged. I want to add episode and say git commit dash m. Actually, you know what? Yeah, git commit dash m. Added scoring methods to episode equal. So I was considering basically whether I should, for this one here, if I should have this as a temp commit and then revert it, not commit it at all, or if I should just commit it and then undo it later. And I'm going to do that one just for kind of completeness sake, right? Because basically what I was saying is, I mean, I could just get rid of it or pretend it's not there, and but I kind of like having everything in the commit history. So I'm going to say git commit and added temp prints to ut for score tuning. All right, and we'll say git tag at 29. Cool. Okay, so basically the last thing we're gonna kind of do for this, so we're gonna decide on kind of how to weight things, and then we're gonna kind of clean it up, and then you know maybe I'll also add in another a fake one of these and kind of test it out and kind of push it to its kind of limit and see like, well, okay, how much of a difference, right? Because we know these are always equal, and so that's going to affect the weights, because if the description is equal, well then it's the same episode, right? If this is equal, then it is the same episode. So those are kind of strong weights. In general, if this is equal, right? The thing that really changes is this title. Everything else is kind of equal. So, and the title makes sense that it'd be different because, right, it doesn't, the one on the main feed needs to say what podcast it is. And the one that's on its own feed doesn't need to say it because you're on that feed. So this title should really have the lowest weight, and these should have higher weights, right? But okay, well, what if, people start, what if some of these things kind of change? So, ads get added to other feeds more often than, a different feed, or they change the way they're doing the MP3, right? What is the limit that we can kind of push it and still get something, right? Like, for example, this is a 1 or a 0. We might actually want to change that or weight this very lowly, actually, because right now it's weighted at 25%. So if this is different, it's 25. If anything else is slightly different, it's 25. And that gives this a whole lot. So we're going to want to lower the weight on that. But we'll, do that next time. We'll do some kind of tweaking and tuning, and then we'll kind of clean things up. And I think then, we'll basically be at the point where we can kind of start writing up some logic to kind of say, hey, this one's here, and we'll do the Twitter stuff. So until then, see ya.